unless we need to welcome back everyone to Robotics 101. It's a training for ag teachers and ag tech coaches. Here again is a repeat of the slideshow links going into the chat. And so let's have a little recap. I want to do this on two levels. First of all, I'd like to talk about the goals for the workshop. And so the first one was to introduce the optional 4-credit portion of the class. And then the microbit cyberbot board and how to script with Python. So for that, we used a summary and did some hand typing between the Python summary and the editor to simulate that. And then, of course, there was reading material in there too, all designed to help you and students become more familiar with Python. We also had, am I not sharing? Can you see the sessions slide? Okay, very good, thank you. And we talked about resources, the one little summary I wrote you, as well as there are links embedded earlier in the slideshow to learn.parallax.com. So for example, coming back in the slides to, I must have passed it, there it is. Okay, the Cyberbot tutorial series. In the prerequisites, there is getting started with the microbit, and then for getting familiar with Python, writing microbit programs is a full chapter that you can go through, put this side by side with the microbit Python editor, and as you read and try things that it suggests, make sure to type in all these scripts rather than copy and paste them. It will put you in much better stead for explaining things to the students. Okay, back to 94. Or pardon me, 91. So that was session 1. Now, session 2, what we did was, after some homework putting together the Cyberbot robot, we adjusted the servo speeds so that the robot would go straight, and also learned how to make it go forwards, backwards, left, right, and correct for curves. In session 3, we did contact and environmental sensing. For contact, we did the whiskers. So that's pretty nearby here, right here, slide 77. And so these are links to the whiskers chapter, which took us step by step through building the whiskers, understanding how they work, testing, and then the actual code for performing the tests. And then we had to do some troubleshooting and find circuit mistakes from, and I don't actually remember if we had any circuit mistakes, but students will. And so it is important to be able to go back through and ask students guiding questions to where they might have missed on their circuit placement, or in other cases, what mistakes they may have made when typing in their code. Oh, sadly, I was also right at the environmental sensing slide. So we also did environmental sensing, and in our case, what we did was light level and used that to actually park the Cyberbot, assuming it had gone. It is an agricultural robot on its way to somewhere that is darker than daylight, and so it would then shut down when it enters the barn. Next up, in session 4, we did QTI line sensing and navigation. And so essentially what that was being able to follow. We added sensors to be able to detect the road, and then added navigation based on the detections of whether the left or right was either on or off the road to basically make a corrective turn to get back on the road if the robot has drifted off. Then we worked on integrating sensors for navigation. And the example from session 5 was to say, hey, all right, we've got a light sensor, and we did this some in here too, but essentially the challenge is, okay, we had line navigation, and then we had light sensing, and those were in 2 separate scripts. And so one of the activities we did at the beginning of session 5 was to take those 2 scripts and integrate them together. And what that ended up being was follow road, park, and barn. So we had following the road on its own, and we had stopping when shade is encountered. And we talked about how to take only the relevant commands from one working script and integrate them into the main loop of the other working script. And the end result is also in there. It was okay. So it was photo transistor stop and shade. Sorry about that. That we had as one example where the robot was moving, and then when we cast shade, it would stop. And then the second one was pavement following. And so the question was, how do we integrate those two? And when we did, we got to follow road, park, and barn. And again, these are all downloads available to you. So you can get these and examine that progression. Also, in session 5, we did the Husky Lens introduction. And so that was here with the farm robotics analogy. And then this is a link to the kit. And then this is the chapter, which has most of the same warm-up chapters as the Cyberbot. So these are usually already done by the students once they get to this point, so they can start here. And so we built our Husky lens, and then we learned how to train it to detect a color. And then for homework, we had trying out adding the SD card and remembering some settings. And then also recognizing a face displayed on your phone in front of the Husky lens, and backing up and getting out of the way when a person with the right face approaches the Husky lens. And that brings us to today. And today, incidentally, is our final integrated challenge and review, which we are in the midst of right now. Okay, so TEC 1940-2026, this is available at Fresno Pacific or through Fresno Pacific University. And it's an $85 for one semester unit class that was paid by any attendees who wanted to get the unit by taking the class and doing the additional assignment to pass the class. And so that is something that we talked about on day one, and then this was the link to register. I repeated these slides here, and so the two assignments, in addition to attending all the classes, is to complete a final integrated robotics demonstration, and then submit a short classroom application reflection, which is essentially, at least the way I see it, is to essentially set up a class activity and then reflect on it. Are there any questions about that for those of you who are attending or who are taking the class for the credit? Either Eric or I can help you out with that. And if it's a how-to, go to me. If it's I'm getting graded on this, Eric, are we having them submit this to a shared Google Drive? And
we're gonna, yes, we're gonna put it. Oh, hang on.
That's quite the echo chamber.
That's weird.
Yeah, I can only see one microphone from you, but
yeah, I don't understand.
Maybe two speakers. Maybe
if you turned, I see a second Eric, so I'm guessing that you're attending on two. And usually, what happens is either one of the mics is on or one of the speakers is still on. But once you silence the speaker on the second device, usually that takes care of it. Now it seems like you silenced the speaker on the first device. Oh, yeah, because you're muted currently. Eric, you are still muted on both devices. I think if you unmute on one, hopefully that will do the trick and we can hear you again.
Does that work better?
Yeah, you sound good now. Yeah.
Okay. Sorry about that, guys. The for working on this Fresno Pacific class, you can still sign up for it through the end of February. So get your name in there, and I would say these are inexpensive units as far as teachers go for those who are interested in trying to advance on a pay scale. As far as the app, what we're trying to do is put together a folder. Ari put together a folder. I know Travis has a wonderful set of documents as well. And we're going to put everything into Ari's folder and then make it available for everybody so you can save all the documents and resources for future reference. So that's our target. And then if you make a lesson or something, we'll add it into the folder as well so that it can be used by others.
So that's where you'd like us to turn in our lesson plan. Sorry if I missed that.
Yes, please.
Yeah, and that to me is one of the places where win-win really means win-win, because because essentially turning in all the turning them all in a shared repository will allow all the teachers to be able to use that potentially in a robotics primer class for their students prior to working on the robotics competition. Eric, did you want to do a repeat discussion of the Farm Robotics Challenge page?
Yeah, that would be a good idea.
Okay, let me unshare my screen so that you can share. Or would you like me to continue for a little bit until you're ready?
I can open up the website real quick. Yeah, why don't you continue and I'll come back to me.
Okay, yeah, because that was a little out of the blue. Sorry about that.
That's right.
Okay, so let's go on now to the final integrated robotics challenge. So what I had in mind for everybody was to essentially set something up that treats plants on the road side. Should be specific about that. On way to the barn. So we're not killing weeds on the road. We're treating the agricultural plants. And so what I have for you is a very slow moving, and it doesn't necessarily need to go any faster, proof of concept version of a script that puts together everything, including the servo, the standard servo control that we did at the beginning of the previous session. And I'm trying to get the chat up here. Okay, so here are the links. So this is the follow and treat plants proof of concept. Now this won't work straight out of the gate. I will be showing you how to get this running. And I think it'll provide a pretty decent example for study as well. One other thing is that I will probably make some adjustments. I made a few last minute adjustments just before the start of the workshop today, and I need to put them in maybe at the top so that they're configurable adjustments rather than things that are hidden and really difficult to find deep inside the code. So let's see here. Now, hopefully, can everybody see the, oh, I jumped back. Can everybody now see the robot and code? Okay, very good. Going to try to adjust this a little bit. First, I'll demo the getting started version, which the way I see it is that troubleshooting your sensors, which I'll be available to talk with you about, and the like, is going to be really enough work. And so I gave you what I hope is a pretty strong piece of starting point code. And now when the code is running, I will go over the calibration steps shortly. But what this code will do is when you have, when the, okay, this is difficult to see as is. I'm going to try to bring the camera in closer here. Okay, so in the background, I have a picture of a potted plant. Okay, so we can see the lower stylus is actually the actual picture of the potted plant. And then inside the blue bounding box on the Husky lens, we can see that it recognizes the potted plant and that it gave it the ID of 1. And that's going to be crucial, is going through and setting that up. And when we set that up, which we will do in a little bit, we'll be using this little button to remember things and the rocker switch. And those were part of the learn pages you went through on Well, I'm sorry. Previously, we were using the microbit, but we are going to use these direct controls on the Husky lens for this one, just to basically get an idea of how to use the different tools um, for adjusting the Husky lens. So we've been using tools that were hard-coded into the script, and this time we're going to instead just remember the, uh-oh, what happened? I think I bumped something. Oh no, the phone turned off. Okay, so now we're back. Anyway, we're going to use these tools to go through the little menu system that's built into the Husky lens to learn it. Now here is the script, and I have not really correctly updated it. Like I said, I'm going to send an update of this script. Of particular concern is that the script was too large, and so I went and actually did some pruning on the Husky lens library. So this is not the stock Husky lens library. So careful if you use this script along with its so-called Husky lens module, because it will not contain all the features. And so that would be a reason to go to learn.parallax.com to get the latest Husky lens module and add it to your project if you need to work with it generically. Okay, so with that said, this script has a fair bit of code in it, but what it is mostly is, see here. Remember from our so it's mostly this gatekeeper application from our Python Cyberbot Husky Lens folder, and then our follow road and park and barn application. So let's take a look at those quickly. I'll save this just to make sure I've got a copy. All right, so here is follow road, park and barn. Let's talk about it briefly. So we have modules for the Cyberbot. So that would be like bot servo speed. That's where those come from. And also, let's see here. I think that's primarily, that's all we need from that one. And then we also have reading the QTIs. So QTI read, that is from the qti.py module. Here is read down there. And then intbits is just a way, is a little thing where we can take the result, which is a value with binary zeros and ones, and in that case, so 0 equals 1 equals 2 equals 1 0, and 3 equals 1 1. So that's counting in binary. So what if you were to print the decimal version of this pattern of detections, you would see a number that's either 0, 1, 2, or 3. But the way it turns out is that that is white surface in binary, white surface, black surface, white surface, and both surfaces black. So that is under the hood, just a little side note on what's happening inside the QTIs. And this bit.get is part of int bits. It's just a little piece of code, but it's a lot easier to say bit.get and, look this up somewhere than it is to add this whole segment of code to your main script. So that's why we like to have things tucked away and just basically provide them to people writing Python scripts so that they don't have to write all that stuff. Okay, now we did have to write a custom QTI detection function, and then we have this main loop that repeats over and over again. And the first thing it does is it reads the voltage. And again, this is where we combine two scripts, because we had one script that basically read the photo transistor and then converted that to volts. And then we went through and calibrated each for our own situation of, what constituted being parked under the shoebox, i.e. the barn. And then we turned the servos off and then left the main loop using a Python keyword called break. Next up, we grab the left and right QTI values. So that jumps up here to QTI detect. It does a lot of work and also displays on the microbit and then returns us the ones and zeros from the original measurement. It splits them into 2, 1, 0 measurements and then sends them back, and they get plopped into our own QTI left and QTI right that's in the main code here. And then we use if statements. That was the deciding part. So like this is repeating and this is deciding. And then we have let's see, in terms of memory, here we are storing some results. In terms of calculations, well, here's a mathematical comparison. And then, of course, like I said, we have the infinite repetitions, the endless repetitions, and then we have a chain of decisions here. And and then here is communicate down below. So we have a chain of decisions. We say, well, if they're both 1, keep going straight ahead. However, if the right sensor has gone off the road, back up on the left wheel and go forward on the right wheel so that we can get that that right sensor, I hope I said right sensor, back up or essentially turn left in place so that we can get that right sensor back over the road because it's obviously drifted off. And then we have the inverse for when the left sensor is off the road. And then there are lots of ways to handle when both sensors have lost the road. And I'm not really sure that backing up is the best way to do that. That's what's here. But actually, normally what I like to do is just take no action. And that's the statement for that is pass. And the reason we like to do that is because one sensor probably fell off the road before the other one. So it's probably already doing the right maneuver. And if we just keep on, taking no action for a while, it should drift back onto the road. Anyway, so that's a review of follow the road, park in the barn. Now the other one we had is, did I not download it? Looks like I still need to download that one. Well, actually, no, we're good because that is a combination, again, of pavement following and phototransistor voltage stop and shade. So we put those two together and we got this. So now this is our new building block. And then the second building block that ends up being necessary for the final project is the example script from Gatekeeper Robot. So this is the Gatekeeper Robot script. It's 45 lines. And essentially there are key things in here, like we can switch to an algorithm. We don't want face, but we can switch to an algorithm for recognizing. And I actually cast aside the loading from SD for this example. You'll see in a minute, or in a few minutes. And then essentially it looks for, hey, did we press a button to load, to change the ID of the face that we're looking for? And then if we ask for the Husky Lens for data and it comes back with something, then we can essentially make a decision of whether or not to move out of the way. And so that is this script in a nutshell. I'm not going to go into it too deeply because you'll have a script to examine and to tune along with your sensors and mechanical setup. And that's really going to be enough, I think. And for that matter, I actually wanted to use this as an opportunity to talk a little bit about the more modern workflow with AI in the party. So remember I said that we had two scripts. We had follow the road and park and barn, and then we had Gatekeeper, which again, this is an application where if it sees a particular face, the robot gets out of the way. Otherwise, the robot just displays a X on its microbit saying basically access denied. And so you can show it different faces like oh, that's right. The training happened in an earlier chapter. So that was right here. I'll go ahead and paste this in. So this was the face recognition training. And that chapter is essentially building on that. One of the fun things is that you can actually use the faces right on the computer screen to do the training. And it even works okay if you have a color printed one later, though. If you do it with the color printed one specifically, it's going to help out a lot. Anyway, so this is the application where it used this face training. It was saved on the SD card, and then it used it to remember to get out of the way for one of the three faces and then refuse all the other two entry. Along with any face that didn't have an assigned ID. Okay, so again, we have the Gatekeeper application as a building block. And then we have the one we've been working on in class, which is follow the road, park in the barn. So now where does AI come in on all this? Well, the answer is, all right, ChatGPT. Let me see if I can get to the beginning of this. It's turned out to be 38 pages of conversation. So I'm posting a link for you to look at it and see how this works, but I'm not expecting everybody to. Okay, so here we are. So what I told it is, hey, ChatGPT, I have a cyberbot following a road with this script and parking under the shade, pardon the misspelling there. I'd like to use key elements of cyberbot gatekeeper Python. That's the second script I'm pasting below, and it'll pick that up. To make it so that the Husky lens mounted on the side of the bot detects a plant and then turns to face it briefly, then resumes its navigation down the road. Now that ended up evolving as we were doing it. So I pasted in, follow the road, park under barn. Here's the whole script. And then below it, where is it? There's follow the road, park under the barn. And then here is Cyberbot Gatekeeper Python. So I gave it both building blocks. And it thought for about 20 seconds and then spit out this giant piece of code. And great. Does it work? No, of course not. It actually never does on the first try. And I haven't counted the iterations yet, but I think there was north of 10 iterations on this. So then it gave me some helpful tips. And so I said, good, yes. Please minimally modify this for HL, and it picked up that I meant Husky lens, HL training. Also, so because what it did was it grabbed an existing training set saved on SD that wasn't very constructive. Also, I'd prefer to just recognize a potted plant. So it assumed that we went through a lengthy training session for the potted plant, which is not something I'd planned on. So what I decided to do was adjust it to use the built-in, potted plant functionality. And then for anybody who's interested, we can go further into training the machine vision. But I really think this is enough. And then since I ran the script, I found out that it essentially ran out of memory in the microbit, that there was just too much weight in the way of modules, code, comments, and all that stuff. And so I said, wait, we'll hit that later. The first thing we need to do is some trimming. Do you see any candidates in the Husky lens module? The microbit ran out of memory. And so I pasted the entire module, and that's this one right here, let's see here. Let me open it. I'll just open the, okay. So this is actually the trimmed module. So okay, so I trimmed it down to 383 lines, and now you can see why we ran out of memory, because there were a lot more lines taking a lot more memory before this. So this is what we trimmed it down to, and maybe I can even show you what it was originally. Let's try this one. No, it wouldn't even save. I'd have to go back to yesterday. But anyway, suffice to say, it had a number of more lines than this that took a considerable amount more memory. And after removing it and reducing the module to this smaller size, now it actually fit in the memory. And that was something where I had to go back and forth. And this is not something that we'd expect a user to do. It was kind of a learning experience and a step along the road of essentially improving this Husky lens module for the end user, because running into this challenge here means that other people are going to have that too. So a version 2 of the Husky lens is something that we're going to be thinking about. So anyway, it gave me some suggestions, and some of these suggestions turned out to be utter suicide. I mean, if I'd have gone into this, we'd have had to, if I had followed all its instructions, the resulting debugging, because the chatbot hadn't really considered the consequences of some of the things it was suggesting, would have had us doing this next Monday instead of this Monday. But that also would have been the case if I had to write this code myself. And um, so that is, there, provided you've had some practice with this, there is a time savings. And so anyway, we went back and forth on updating the Husky Lens module for a while. And I ended up saying, hey, why don't you tell me about what has to do with following lines? And it talks about arrows here. And it gives us arrows when it detects a line. It shows the line as an arrow vector, and reports it that way too. And so anyway, I was interrogating ChatGPT on where I could find things to get rid of, and the one thing it did suggest that I acted on was getting rid of all the line following code, which adds up to quite a bit of code actually. All these function names had lines of code and took up memory, and after removing them, we got plenty of memory to work with the to get the proof of concept to work. And so then we went on, and I don't know what this is. I think I pasted in I pasted in the version so that it was synced up with what I was working with. Anyway, and then it made some suggestions, and so this is the kind of back and forth that you end up doing to develop code with a chatbot. Now we have, I want to emphasize, some much simpler examples of this. And they are in, I will paste you in a link to it. It's in Cyberbot. No, it's not. It's artificial intelligence with Python. Okay, so this right here is much simpler, and it chronicles the adventure I had today in a somewhat more step-by-step manageable fashion. And so the way it starts, for example, is with the recording of an older conversation with ChatGPT, where the questions were much simpler. The code was much smaller in scope. And in this example, I asked it to display a heartbeat. And I believe that this code example did work, but it's not really the recommended way to do it. So we introduced this iterative coding process, and talked about reviewing it, that that at this point, this is something that a student has already tried out once, the beating heart. So they actually know about this particular script. And so simply asking for a better version that's using the built-in features of the microbit instead of creating your own heart shapes to do the beating heart is good. Then we went to tilting the microbit and having it always point downwards regardless of what direction you rotate it. See how there's a line downward here, and then it's rotating and there's a line downward there. Well, that's part of the tilt control. This is something you can do with your Cyberbot. If you have two Cyberbots in the classroom, you can grab one and tilt it to drive the other Cyberbot around. Students really love this, and if you happen to have a sumo ring nearby, and you're ready to have them only thinking about sumo wrestling for the rest of the class period, you can have them set their robots on that and try to push each other out, and they end up having a lot of fun. At any rate, what happens here is that this is where we ask for something, and the first script doesn't even run, and then the second doesn't work properly, and we go through essentially this iterative development of checking and testing and explaining the situation, and then also using an understanding that the student has developed of how a script should be done in order to get things to work right. So this is a much simpler way to do it. I pasted in my chat just so you can look at it if you want to see what happened, or how a deeper level development session goes with a chat bot to get to some end code. All right, with all that said, let's take a look at what the code is supposed to do. And then I'm going to walk you through teaching your Husky lens to recognize a plant as I have done for mine. Okay, so we'll go ahead, and I think I don't even need to send this to the microbit because it's already there. So instead, I'll just switch over to the not exactly in focus. Okay, much better. Okay, so what I have here is pretty much the same setup that we used from last time, in that we've got, it's just that I connected the servo to one of the standoffs that was holding a whisker. And then, just for the sake of having something on here, you know, in a classroom where there are students and more, you know, prototyping and even machine shops or 3D printers, we can make a fairly elaborate sprayer, but I just put the wrench in the kit on the servo horn to demonstrate that we have a sprayer going. And then again, the potted plant is trained so that we see the blue bounding box, and that it does figure out that we have a potted plant here. So then we have all the line following, and what I did was just added essentially the ability to stop when you reach the potted plant, and then move the servo to be like moving a sprayer or a fertilizer application system into place, and then move it back out of the way. Oh, pardon me, that didn't show. So what I set it up to do was have it move the servo to bring the end effector, whether that's a sprayer or a fertilizer application system, into place, and then it'll do its thing and then move it back out of the way so as to be able to move on. All right, so with that, then I'm going to basically turn off everything and restart it. And then it should come on to the Well, all right, I'll go ahead and load the modified program into it again. Maybe I put something on there. Here we go. Okay, so once it sees the potted plant, it backs up, moves the fertilizer, or moves the implement, and then it continues to follow the road along. And I think actually um, my my light sensor calibration might be a little off, because it stopped as I was doing something else and waved my hand over it, and you couldn't really even see that anyway. So we'll do one more. Okay, so here we are limping along, which is important when you're at the prototype level. So it backs up, applies the fertilizer. That still was not in view. Regardless, I think you get the idea. And so we can, this is something that it basically works, and it's something that you can experiment with and see if you can get it running in a more full featured, or well, just in a better manner, where possibly you'll have a couple of color printed trees and a long course, as opposed to doing it under the document camera. Take a film of that and turn it in for your for the want to make sure I say it right, for the final integrated robotics demonstration. And let's see, with that, before we go on break, I would like to have Eric pick up and show the Farm Robotics competition webpage again.
Okay.
See, I need to stop my share. There we go.
Hang on there, sir.
While Eric is doing that, I do want to mention that starting very slow is crucial to the prototyping. But as you increase the speed, you can end up inserting new challenges into it. And frankly, I would not go for a super high speed. I would just, the main thing is going to be reliable functionality. And if you are able to increase the speed somewhat, that is like a bonus. Okay, take it away, Eric.
Okay, you got me on it. Is it okay, Andy? Can you see me and
It
hear
looks
me?
great, yes.
Okay. Ultimately, the Farm Robotics Challenge is an opportunity for students to participate in an opportunity to compete doing what I think is called a three-circle model project. Three-circle model, we're familiar with it. It's a curriculum, it's leadership, and it's a project. So this is your project is to go out with a farmer, find a project on site, have the kids meet with the farmer in the field, bring it back to the classroom, discuss it, develop a pattern and a proposal, and then continue to have the conversation, and then solve the problem using technology. Now on this website, you can see we're using, this is the Amiga tractor. This is the educational model, if you will. We do have drones that we can use. We can use AI. We can use Chat GPT. We can use all the different technologies that you can think of. And as we're starting to learn, there's many, many more. Some of the things that are coming out of this conversation that we are having, a number of our ag students are saying, I want to be involved in the technology industry. And so logically, they have been pre-programmed to think that means go to Silicon Valley and start your career. When they do that, they leave a vacancy locally in our hometown communities And so one of the reasons that we have this project is because we want to help our hometown kids know that there is technology in their local hometown. Right now, I was just reading some articles this last week, and you guys have read them also. John Deere, for example, many farmers are putting away their brand new $500,000 machines to go back to a 1960s and 70s model tractor. So, because John Deere has become so proprietary that they've locked everything down. Even if you can replace and you identify what has been broken and replaced, the machine will not start to operate again until a technician, who you have to pay for, comes out and puts their code into the work that you just did. It's sort of like giving a tip to somebody at the restaurant who didn't do anything. So,
And it's sort of like a tip that's thousands or tens of thousands of
totals.
dollars.
So, one of the, I talked to a gentleman the other day who is in the Silicon Valley industry, and he's saying, "Hey, your kids are really good for teaching them how to manage people and projects. Our kids come to the Silicon Valley and they are prepared, which is amazing in the leadership character, in the leadership side of life, but they aren't necessarily skilled in the technology." Okay, so that's one asset that we have. The second asset is that in our local communities, a lot of our Silicon Valley kids are saying, "I need a job, so I'm going to go to the farms, to the ag communities." It's going to take them 3 to 5 years minimum to catch up. To because most of them, many of them do not have common sense and practical application skills. So one of the purposes of this academy is to get ag kids into their local communities, understanding that technology is reality. Um, I live in the Davis area, and many of my growers and chemical companies, the PCAs have drones on their trucks. Our construction crews have drones in the field. Our airplanes, they all have GPS on them. Trucks all have GPS on them now. So everything's got the technology built in. And so and we haven't even talked about military applications or public service, fire department, police, uh, their applications, movies. We're hearing Hollywood's having a hard time right now because many of their operators that used to be driving cranes and gantries, uh, the industry is going to drones. And so it's a big, big deal. So this is an opportunity for us. National FFA is involved with us now at this point, and we are considered a preferred vendor for them. I think that's the word for it. The purpose of them doing that is I talked to North Dakota chapter this morning. They are going to be competing in this competition as well. Right now, this competition is California specific. Um, but there's a lot of industry that's starting to participate with us and become partners. And so we're very excited about it. Um, we're starting to see one of the things that I'm going to ask you with a follow-up survey in a couple next week is what other trainings can we provide for you as the Farm Robotics Academy expands and UC A&R is developing future curriculum for teachers and for students. So think about that. Um, Nobody's going to be expected to become an expert. I would have been in the technology industry if I were to take it back 35, 40 years ago, but I didn't. I chose an ag teaching industry. I did a lot of shop, I did a lot of greenhouse, animals. Technology wasn't part of my game. So now, but I'm interested in technology. So how can I bring it into my classroom and make it exciting and make me and my students valuable to my community? And so that's what this is all about. We're excited. And we're not just at talking FFA. We're also talking 4-H and other student organizations. We have teams that are not even part of the agriculture youth programs that are participating because they said we want to participate as well. So that was an instructor decision. Future for us, you guys are all part of the first round of grants. We are not going to go out and get new people in the grants. Next year, the money will continue. You guys who've already been told you got the money, count on it. We're not taking new applications for that. Yes, we're 6 months late. That's beyond our control, but we are going to get it out there as soon as possible. And one thing, and Andy is going to bring it up later, I've seen his slide deck. You could possibly even use some of the funds to buy, for example, a classroom set of cyberbots and have a whole sumo competition in your classroom. So just an idea. We appreciate Parallax and all that you guys have done, Andy and Ari and the rest of the crew. Thank you very much for all of your participation in this event. So
thank you very much, Eric. And we'll be looking forward to feedback on, how this fits in the long run. Like I think, this was our best shot at making it a stepping stone to the larger ag robots. And I'd like to find out in the long term if students responded well to using a cyberbot to get some of the basics under their, to acquire some of the basics, and if that worked well expanding to the larger robots.
I think it will, Andy, and I think the key is that yes, we need the kids to expand, but it's also an opportunity for us as teachers who've probably never been exposed to or had very limited exposure to programming, the basics of what's under the hood in your cyberbot. It gives us the understanding so that we can be confident in our presentation of curriculum. We might not be proficient, but we can definitely lie, just like the rest of them.
Well, yeah, this provides a starting point. You've still got a lot of work ahead, but
Yep.
but we also have additional chapters to be read on the site. Okay, well, this is great. Let's take a break and resume at 5 o'clock. All right, welcome back, everyone, from the break. What I would like to do next is, first of all, go back to the main script. What I would like to do is show you how to train your cyberbot to, by the way, I do have some background noise. I'm hoping that I get head shakes. Is the background noise making it through to you, or is it? Okay, very good then. Okay. All right, so what I'd like to do is show you how to train the Husky lens so that it will recognize the potted plant. So let's get the potted plant up and move the lights away so that all right. Okay, so can everybody see this okay? That it says potted plant ID 1 in the blue bounding box that's looking, that's in the Husky Lenses screen that is looking at the potted plant that I'm showing it on my cell phone. Okay, I've got one thumb up. Okay, excellent. So the way the Husky Lens works is that it has a menuing system, and to get to that menuing system, there's a rocker switch on the upper left. And so that you can press to enter the menu. Do you see how the menu came up? And your menu will probably appear either in, say, face recognition if you were doing the Gatekeeper app, or color recognition. And so that is displaying along the bottom. Maybe I should go in a little bit closer here. All right, let's try that. Okay, see how it's showing color recognition? And my phone just, okay, there we go. Okay. So again, when you hit the rocker switch to press it down, you can then go right or left to do the different, to make use of the different features. And in the Python script, it's fairly easy to also switch between these features. And I've noticed just that it's less confusing to follow specific instructions on how to use the microbits button to do that. But for this one, we'll go ahead and use the one moment. The background noise has gotten to be a bit relentless. I'll be right back. Okay, I think I'm back. My former feline office partner just could not understand that I was doing a presentation without her being able to be in her office chair next to me, as she was all the way through COVID. And she could hear me doing Zoom in here and was out caterwauling on the other side of the door. All right, so returning to the instructions. Okay, so let's see if we can get back. So here we have our potted plant. And the way to do this is to go to Object Recognition. And then to enter the Object Recognition menu, all you have to do is press down on the, press down on the rocker switch and hold it for a minute. And then you have submenus. So for example, save and return once you're happy with everything. And then there's a whole, quite a number of features here. And then save and return. Well, we want to go into learn multiple. And when I press learn multiple, there's actually a little on-off switch that's appearing that's translucent. And if you hit the rocker switch to the right, it'll turn learn multiple on. And if you turn the rocker switch to the left, it'll turn multiple off. And it's okay to have learn multiple on, I think. And then we can go back to, and then you press down to save the data. So again, object recognition, you press down the rocker switch once to bring up the object. And you can do it a different object if you want. Let's see here. I don't have one handy, but I wonder if it would interpret the Husky Lens box as a television set. No. At any rate, so it recognizes a potted plant. So I'll press once and then press the rocker switch left and right to get to object recognition. And then I'll press again to go in. And then I'll press a third time after, after making my way to learn multiple, press again, and then you can rocker switch left for off and right for on. And so we could learn multiple of the potted plant objects. Now, what I can do next is there's a button on this side. So this is the rocker switch right here. And then we've got the button over on the other side. And if I press the button, I can click again to forget it. And when I forget it, this shows us what you will see the first time that you go into these menus and set it for object recognition. It'll say, hey, I see a potted plant. And the only problem is that it's not enough to see a potted plant. We need to give that potted plant an ID. So while, and there's some little crosshairs that you can put right in the middle of the potted plant. So once you've got a fairly steady, hey, I see the potted plant, you can press, and it took that moment for my phone to go to sleep. Okay, potted plant is back. Now you can press the button again, and it is learning the potted plant and giving you some time to say, I want to unlearn it. And that is all it takes. Now your Husky lens has that ID, and that is the ID that the script needs in order to say, hey, I see that potted plant. So if you have not gone through this step, if you do not have it so that when it sees the plant, the picture of a plant that you use, if it does not display potted plant :ID1, this app will not work. But if you've got this set up, it works. And I have tried this a couple of times. I just want to make sure right now. I'm going to unplug all power. So power off here. Okay, so the power is completely off. Now, when I turn the power back on, I might need to go back to object recognition, or it might just go straight back there, but I believe that it will retain this setting. Okay, so I just turned it on. And yes, so it's still back in object recognition where it left off. And for our situation, it still has the potted plant and it remembers the ID. And notice that when the potted plant faded away, it stopped displaying the ID. And there it is back. All right, so let me get you a couple of scripts because there is one thing that we can go back to this and go almost to the end. Like I said, 38 pages. There was a really helpful can we see it script. And then there was more unhelpful advice that I realized. So I apologize, it's taking me a minute to get to it. Okay, so this is an attempt at one of the last attempts. Okay. So since ChatGPT knows that this is a training project, it even gives me little teaching tips. It's not bad, really, although I didn't remember, you know, I talked more about communicate, remember, calculate, decide and repeat, and kind of missed the pedagogical gold moment that it was referring to. All right. Let's see here. I apologize. I did not grab that script, and it apparently is further back than I realized. This looks like it right here. Oh, darn it. Let's see here. This is still the full robot script. There was a nice, small, compact, did the manual settings work? And I believe we've finally gotten to it. Okay, so I'm going to run this. And so we have this saved already. So I'm just going to paste over it. And then check if settings are correct. I think that's a good name. And then I'll go ahead and paste this in the chat. Hashtag. Okay, so if we run this, and then go back to the camera, notice that we see an X. Oh no, you can't see that. Okay, so we have an X on the microbit because it does not see anything relevant. Okay, so when the potted plant comes back, the X turns to a check mark. So that's basically the test that needs to be passed before you move on to running the main script. And now I'll copy this and paste it into the chat. Okay, so that's the test script that we just ran. And that one is very similar to the training we did to recognize a particular color that we did last time. And so this script requests the data, and then it says, hey, do we see a block, an acknowledged thing like a potted plant? Now it will also detect cars and whatnot. Okay, and then this is actually, unfortunately, I believe, extraneous code. It's essentially just getting the X and Y coordinates, the center of that bounding box, and that's not really needed. What is needed is this display.show image.yes, which is what gives us a check mark. And then here's the optional diagnostics that ChatGPT helpfully provided, but are not needed. And then if we don't see the image, so, I could really delete all this stuff and it would be a much simpler script. Okay, that does look a fair bit better. Okay, and so if we run this just to double check and make sure that it works, I'll paste in this lighter weight script. Okay, so here we have the check mark. Now we see it. Now we don't. We went to an X.
So Andy, I sent it across and it shows potted plant, but it doesn't show potted plant the ID
The
one.
ID one. Okay, very good, very good.
So
So
now that
I'm going
now that
to,
being
or well,
that being
rather,
said,
okay.
I was messing with the Husky lens, so I don't know if I deleted it from the Husky lens. Could that be a thing? It still
Well, okay.
pops
So
up
first
potted
of all, do
plant.
you have a picture of a potted plant like on your phone?
I'm looking on my computer screen, yeah.
Okay, so you got the email and we're able
Mhm.
to, because I forgot to give you the potted plant
Yeah,
image. Let me.
I clicked your link, clicked open, and it's on my computer screen right now.
Okay, perfect. And I'm sending that to the chat so that anybody can do it. Okay, so you're at the situation where let me make sure I heard right. It tells you potted plant with a white bounding box and no ID.
Correct.
Okay, so that is, I just clicked it once and I'm clicking again to forget. Okay, so hopefully you have something similar to that where it's the white bounding box and no ID. Is
You
that
got it.
is that it?
Yep.
Okay, excellent. Now to get to the ID point, the step is to press the rocker switch, and then you'll have a menu on the bottom, and you'll have to press it again. You'll have to use the left and right rocker switch to get to object detection. Where's my pointer? Here it is. Okay, so now we have object detection there, and then press down to enter, press and hold to enter the object detection submenu. Now you want to, I believe we want to have learn multiple on, but it doesn't really matter. Well, I'm going to leave it on, but it occurred to me that that might be counterproductive. Next, you press down on the rocker switch to essentially accept read multiple. So you hit learn multiple and you can turn it off and on. And then once it's on, just accept it and then use the rocker switch to go left and then press the rocker switch down to hit save and return. And we want to save our data. And that's not the main thing. That's not why you don't see the blue ID on the potted plant. The reason for that is actually, and because all you need to do is hit this button once and then wait until it's done learning the potted plant.
Got it. Thank you.
You're welcome. And sorry about the snipe hunt through the menu system too. I want to test one thing real quick. Okay, so I'm going to forget the potted plant. And let's see if that learn multiple setting does make a difference. I'm going to turn it off and save it, and then save and return. And I hit it twice to confirm. Okay, now whenever you hit this button, it allows you to forget. And I hit it a second time to forget. So now we're back to the white bounding box with no ID. Let's try hitting it one more time. It should automatically give us ID 1, but it's not going to give us the option of learning more different potted plants with different IDs. Although I think the way the Husky lens is set up, the car will get the ID 2 and the television would get the ID 3. I'm not sure if we can give different potted plants different IDs. Again, this is a microcosm of the more full-featured Amiga vision system. So anyway, everything I said about needing to remember multiple IDs, I don't think matters. And I don't know if I could find maybe we can try this with faces. Okay, if we consider our objects to be faces, what I'm going to do next is enable learn multiple again. Okay. And then let's see if maybe, no, it doesn't figure, it needs to be in facial recognition to learn multiple faces. And I'm not sure if I can find another object. Let me see if I can real quick on my phone on the web pull up a picture of a TV set. Okay, so TV, images. I don't know. Let's see if this works. Nope. Oh, how about car? Cars should be more recognizable. Go. Okay. Car. All right, so let's remember this car. Well, wait a second. Yeah, it doesn't seem like it's, well, there's the TV monitor. Let's see if, well, it can see that the blue car is a car sometimes. I don't know. It's kind of flickering, but it does figure out every car, but I have not succeeded in giving the car an ID, even though the object recognition learn multiple is enabled. I don't think it's able to do much more than learn one object. And if some of you experiment with this and find out otherwise, please let me know the trick. Anyhow, with that, with essentially learning your potted plant object, that's that plus the proof of concept script should be enough. What you'll need to do, of course, is mount your servo application device, and then the previous circuits like the light sensor and the QTIs will all need to be functioning. And if a wheel falls off, make sure to put it back on. Notice that I took off the O-ring tires. The reason for that is because it seemed like I was getting a little bit better detection without the extra height of the O-ring tires. And so that was kind of what got me past the QTIs not reliably detecting the black stripe. Or pardon me, actually not reliably. For me, it was reliably detecting that it had gone off the black stripe. So those three subsystems from the previous sessions you'll need to have running, and then train the Husky lens and try out the script, and then make sure to adjust the script a little bit and possibly train on some color printed pictures of trees. You can, for example, have the Husky lens mounted so that it is more facing upwards, and then you could have an actual physical tree, albeit printed on cardstock paper, next to the road. And then the sprayer could be more elaborate too. Upgrade to a straw. And I see folks taking notes and working on their robots, so I'm not sure I want to jump back into slides yet. Also, hit me up with any other questions you've got.
kind of strange. It seems to only remember one object, yet it said car ID 2. But then I went to potted plants and it told me what it was, but I had to clear the memory in order for it to save it. So maybe it just doesn't have the memory capacity to remember more than one object or something.
Yeah, I think the I think the object feature is a little bit less robust in this than the faces. So for the faces, you can definitely assign multiple IDs to multiple faces, but the arbitrary object category, it either doesn't have um, the feature, or I'm missing how to make it work. And I have been missing how to make it work for a while, if that's the case, because it's not for lack of trying.
I was wondering, like I understand that other robots they'll use like for say like spraying or something. You have like a tolerance where
Yes.
if it's like 95%, then it's yes, confirm spray, or if it's like 60, it's like do not spray because it could be lettuce and not, cheese wheat or something.
You don't want the Roundup on the lettuce.
Right.
Okay, so here we go. So again, it's that rocker switch. And this time I'm going to go to the right a bunch of times, and I believe it's general settings. And then in general settings, one cool thing in general settings is there is an LED light. So okay, so that's a fun part. But in addition, and you can even adjust the LED brightness. And let's see here. Okay, this is not the right spot.
Is it the tolerance? What was it? It's like a 3-letter acronym.
Maybe. Okay, let's see
was.
if I'm back in object recognition. And
Yeah.
there it is, the NMS threshold. And I do not know what NMS stands for. So yeah, right now we're at 0.2, and you could go in and adjust that to either increase or decrease it to make it, I believe lowering the threshold makes it more picky, and then increasing the threshold makes it less picky.
Cool. Thank you. So then if you paired that with like just having multiple plants all in the same like memory bank, then it would allow for it to just make that determination there.
Yes. Non-max suppression threshold. Thank you, Corey. That came through on the chat. Okay, I'm going to real quick show you all some additional resources that we've got on the Parallax site. I do want to mention that we have quite a few different lessons that we have not touched. Like here's, remember the whiskers had to bump into something. Well, here's the non-contact version where there's infrared headlights that are being shined out. And if they bounce off an object, they go to the little sensors inside television sets, the kind that you have to point an infrared remote at. And then these lights are actually just like the infrared light that you cannot see flickering at the end of the remote when you point it at the TV. And they make good little object detectors. These are also the same parts that are inside automatic sinks. So the automatic sink has an LED like this that shines infrared light, and a TV receiver like that, now renamed a sink receiver. And so I actually fairly recently had to respec these infrared receivers, because the kind that went into TV control have received so many extra bells and whistles that they're no longer functional for this application, but it turns out that the original TV sensors got repurposed for sync hand in front of detection. And so that's what the current sensors are in the Cyberbot. Did I show everybody this already? The radio control. So like the tilt control, this is one where you can type maneuvers in the terminal, and assuming that all the robots are on the same channel, you could potentially have a teacher station controlling all the students' robots at once as an example of radio stuff. And I think the radio is important because that also can be relevant to data logging. Essentially data reported from the remote robot or robots to a central workstation. And then there's the tilt control that we did earlier. We also have electronics lessons. So for students who want to dive deeper into, or teachers and their classes who want to dive deeper into electricity and electronics, this is a different setup. It does not use the Cyberbot. It uses a collection of breadboards. Let's see if I can get a good picture, probably at the beginning of this one. So it's a breadboard setup like this. And what's really fun about it is that there's a software oscilloscope that that the microbit actually measures the voltages on the breadboard, and this is the actual brief turn the light on style pulse that happens for a fraction, between half and 2.5 milliseconds every 20 milliseconds. That's thousandths of a second. And so this is the microbit graphing these in an oscilloscope to measure the signals. So that's an example of how one can dive deeper into electronics with this. And there is also like basic voltage measurements in this as well. So if we go back a few, here is the electrical measurements. And that same web page, it's cyberscope.parallax.com, can also be used to display voltmeter measurements. Whenever possible, I like to use the actual voltmeter and oscilloscope, but for $20 as opposed to the price of a good voltmeter and oscilloscope, which you could budget between $500 and a couple $1,000 for that, it's a pretty good deal. We also have sensors for the microbit, and there's lots of cool sensors that that we can use. And like here is a plant moisture example that might be somewhat germane to agricultural applications, but we start off with really simple stuff like the push button, and then continue to motion detection, and then to forward direction tilt detection, and it goes on. And we've got like a liquid level sensor, and again the moisture sensor, and then the joystick. And these are all things that can be connected to the microbit and then read or controlled depending on whether it's a sensor or an actuator. A reminder that we have the Cyberbot chapters that we've talked about, plus much more, on a Python page and a make code page. And then there is a subset of cybersecurity tutorials, and which in some cases is nice if you want to make the robot unhackable, and then that could actually extend to making your farm implements unhackable. And then even some of the cybersecurity stuff is available on make code. These are the QTIs, and this is a more, this is the application that Parallax has published, which is following a line using 4 as opposed to following a road using 2. And then here is the TV remote chapter. And we've also got, as an example, a rotating turret. And those are all, oh, and then there's fun stuff like tilt control with a gripper. And again, this is just for ideas if you ended up needing more classroom activities with the Cyberbot. There are sold separately items like this gripper kit that you can use, and the remote control. And I'm using buttons on the other microbit to control the gripper. And it feeds into the various lessons, actually in the prerequisites section. Okay,
Andy, I had a question.
go ahead.
So I found these a while back and started plugging. I have a bunch of electronics kits I've got over the years.
Mhm.
And then so I think my issue I'm running into is where you guys are at on the schematic and do you have like an overall schematic of what we should have at the end of this class? Because I have changed and moved and played, and mine's like a Frankenstein. Like I have the Husky lens on the front, and that's about it, like the bare minimum. I don't have the been building a lot.
Yeah. I'm trying to remember. Right now, I don't have that all in one place, but I could.
Because like my photo resistor's gone. I was like, I've added so many different things and taken things off and moved them around and just to see if
Yeah.
it would work. And then I'm like, you're like, oh, we're gonna do this. And I looked at your guys' today, and I was like, I definitely don't have all those on mine. I took the whiskers off. I took a bunch of this, and I was like, oh,
Yeah, that's okay. So
I can get there. I mean, like if I get a picture, I could probably get a picture of somebody's, and I can make it work and figure it out. But
yes, and I'll if you could send me an email note reminding me to put all that in one place,
okay,
that would be good, and I'll go ahead and put it all together for you.
okay, for sure. Yeah, I was trying to put the Husky lens back on, and my fingers are so fat I had to remove stuff out of the way. And then I was like, oh, we needed that still when I logged on today. So
Yeah, I might actually take a picture of the board. That might help.
okay,
Just put a picture of essentially, if I get a close-up of this at a good angle, we'll probably have what we need. Like if I get a close-up of 2 angles, we'll then have the a view
cross reference and
yeah. And then the schematic part is easy, but
yeah,
wiring diagrams take forever to draw, and I don't think I have one specifically that does all of this, but a couple of photos might suffice.
for sure. Awesome, thank you.
Yes, of course. And we also have servos, like the continuous rotation servos that we've used. We're just setting speeds in the servos. But these continuous rotation servos actually will, oh, sorry, don't want to take the time to watch it. Where are they? Oh, maybe I was in an okay place. I'm not exactly sure where that. Oh, it's because it's the gripper. Okay. I'm going to backtrack a little bit to get to the feedback 360 servo. So if we go to Cyberbot and then Python, so the stock kit supports all of the prereqs and then everything that's in the main lessons as well. But we've got projects down here. And here's the Cyberbot Feedback 360 project. And here's an example of how the motor works, note the marker here on the wheel. So these are optional upgrades for classes that need some precision in motion. We found that for most cases, it's not strictly required since we have sensors that the robot can use to guide its motion and can use things like lines and all that. So the Cyberbot, sorry, these prices are probably outdated. So always follow the link.
I gotta go teach class now. Starts at 6.
Yeah, so follow the link and you'll see the actual price, like 279, 265, 251. Okay, it's not out of date, fortunately. So this is the individual Cyberbot in singles and quantity, but there's also a kit, and this is, I think, what Eric referred to earlier is that this is a kit that has a class pack of 12 Cyberbot robots, and in addition to it, it has 12 of the QTI kits, 12 of the turret, of the ultrasonic distance sensor on the turret, and 12 of the TV remotes, and then enough batteries and chargers to keep the whole class going, rechargeable batteries and chargers. And so, yeah, that's currently marked at just under 4K. And so that's for a 12 pack. So that is just a thing to know is there in case you want to use this in the classroom. And especially if you want the expanded kit. This doesn't have everything, like the gripper and the feedback 360 servos that are precise are not part of it. A couple things. Here's links again, or here are links in the classroom. Replacement parts are a concern. So I added links to the electronics kits and the hardware packs. And I try to keep a few extra of these on hand for students who lose stuff in their kits. I can just pull from these to replenish it, and they're fairly reasonably priced. Like this is under $20. And so getting a few of these kits just to have on hand, like I said, it can be a lifesaver. Here are here's the contact information for Parallax, and especially this education at Parallax. Ari, is the educator hotline still running?
Yes.
Okay, so the educator I'm sorry?
He goes straight to me. So.
Oh, okay. So if you need to ask Ari a question, he's there for you. And by the way, he also has taught college robotics and taught many of these classes. I just happen to be the one tapped to teach this one. So he knows everything I do. And so if you get him, he'll have answers, but you can also, you've got my email address from the emails you've been getting from me before every class, and you can also feel free to email me directly with technical questions, sales, and help I'm stuck in the classroom during regular hours. Those are definitely more along the lines of the educator hotline. Okay, and then there is a forums also, but this email address is the big one because this goes to everybody in the education group in Parallax, and then they route it to the best person to reply. All right, and that is it. I'd like to thank you all for coming to this workshop. I think it's gone really well. We can continue the conversation after the recorded portion, but that is all I've got for this workshop. And again, thanks everybody for coming, and we'll look forward to seeing your projects and class activities in the repository.